Hello students, welcome back to a new class for rational number. Today in my previous videos I have explained about fraction and then I have explained about decimals. Today it's turn for rational number. So what exactly is rational number? As I told you, I have explained about fraction. So there is a lot of similarity between a fraction and a rational number. Now here what the definition of rational number says is rational number is any number which can be written in the form of p by q, where q is not equal to 0 and p and q are integers. Clear? P and q are integers, and if we recall the definition for fraction, any number which can be written in the form of numerator and denominator, where n denotes the part we are talking about and d is the total number of divisions a given picture or a thing has been divided. Now, what is the difference between p by q and n by d? As I explained you, here q cannot be equals to 0. Even in fraction also, I have cleared that d is not equals to 0, because if d is 0, nothing is to be talked about. 0 means nothing. But the main importance is p and q are integers, where here n and d are whole numbers. Now, to this extent, I hope it is very clear to you what are integers and what are whole numbers. If you are unable to recall, just have a very short recap of that. Whole number begins with 0, 1, 2, 3, 4, 5, 6 and so on. Whereas when we talk of integer, this means towards this side also it can extend. Now we can talk about -3, -2, -1, 0, 1, 2, 3 and so on. This says all group of negative and positive numbers along with 0 gives you integer. So this is the major change between a rational number and a fraction. So we are going to deal about rational number today, and we need to refresh the knowledge of fraction for adding the rational numbers, for subtracting the rational number, for multiplying the rational number and for dividing the rational numbers. Concepts are a lot same which you have already done in your previous classes 6th and 7th. This chapter is for 8th standard rational number. So, more than this, we are clear with the definition. What is integer? Integers are negative, 0 and all positive numbers together are integer, and rational number is in the form of p by q, where q is not equals to 0. Now, few more things about rational number. Now, like in fractions, if we need to write the equivalent fractions, what we did? We multiplied the numerator and denominator by the same common whole number. Now, similarly here, if p by q is a rational number, we can multiply it by a and a to get an equivalent rational number. Similarly, by p by q into b divided by b and divided by b, we can get another rational number. Now, how to equate it? Equation means if it is a by b and c by d, we say that a by b is equal to c by d when the product of AD is equals to BC. So isn't it so simpler, the equivalent to process we have followed for fraction? There also, when we find the equivalent fraction, we multiplied the numerator and denominator by same number. Similarly, the same rational number is to be multiplied by same integer. Here again, it is to be divided by the same integer, where b is an integer. Now, to tell whether to compare or to tell whether both the rational numbers are same or not, that means a by b is equals to c by d when if A and D, product of A and D is equals to product of B and C. Clear? So these are the three properties to get equivalent 1, 2 and 3. So instead of becoming afraid of a new concept rational number, it's better to refresh it and note the little difference which we are going to follow. The only difference is there the numbers A and B were whole number, where here it is integer, and the most important concept throughout the rational number to be remembered is denominator is never negative. So how to make a denominator negative as positive? If a rational number 2 by minus 3 is given, clear? Now as I told you, denominator should not be negative, so we multiply it by minus 1 to make it as 2 by 3. Clear? Now here comes the existence of positive and negative rational number. The way we have already discussed about integer, negative and positive. So let me have a short explanation on that. See, we can have 4 types of number. If numerator means 2 numbers are there, P and Q. The possibility is either P and Q both are positive, both could be negative, one could be negative, the other one could be positive, or P is positive and let Q be negative. Clear? Now in this, as the sign are same, both the numbers are positive, here both the numbers are negative. So what I said, denominator should not be negative. If you multiply it by minus 1, this becomes P by Q, isn't it? So both are example of positive rational numbers. Clear? Now here minus P by Q, we need not make any change for Q because Q is a positive denominator. Here Q is a negative denominator. When we multiply it by minus 1, it comes as again minus P by Q. Clear? So this is the example of negative rational number. Clear? So coming next to the property of rational number, let's move a bit forward. Now what are the properties of rational number? Properties, when we discuss about any type of numbers, almost the properties are same. Only thing we need to recap it. Like the first property is closure property. Now closure property says if A by B is a rational number and B by C is a rational number. Clear? Now we need to discuss the property for addition, for multiplication, for division, subtraction and division. Here we will be discussing simultaneously the properties for addition and multiplication, because addition is the basic one and multiplication is nothing but repeated addition. Clear? Now A and B and B and C and D, it's C and D are two rational numbers. We are going to discuss about positive and plus, that is addition, and multiplication. So when we are discussing the property for closure property under addition and multiplication, what we are going to discuss, we see addition means A by B plus C by D, and when we are saying it for multiplication, it is A by B into C by D. Now how you are going to solve this? Whatever number we have, like if we take an example of 2 by 3 and plus 1 by 3. Clear? Now recall the property of fraction. What we will do? The denominators are same. So this is 3, this is 2 plus 1, that is 3 by 3. 3 by 3 is again a rational number. Clear? If we take it as 5, 2 by 3 plus 5 by 3, then this becomes 2 plus 5, that is 7 by 3. Clear? Again, this is a positive rational number. It means when we are adding two rational numbers, the resultant will be a rational number. And how to multiply this? With the same example, 2 by 3 into 5 by 3, it will come as 10 by 9. So when you are multiplying two rational numbers, you are going to get a rational number. This concludes that you can change it for n number of things. In n number of examples, every example will be satisfied, and you can say that closure property is closed under addition and multiplication for rational number. Now, as we have discussed about closure property, now we are going to revise going through commutative law. Now, what is commutative law? Commutative law says that A by B and C by D are two rational numbers. So, when you are adding two rational numbers, what may the order be changed or remain the same, you are going to get the same answer. So, already we have done for whole numbers. 2 and 3 are whole numbers. Then 2 plus 3 is equals to 3 plus 2 is equals to 5. I hope you remember that. In the same way, only thing changes, this becomes a rational number where A and B, C and D are integers, C and D and A and B are integers. Similarly, when we talk of multiplication, it changes as A by B into C by D is equal to C by D into A by B. Clear? Now, if we take example, let's take an example of minus 1 by 3 plus minus 2 by 3. So, when you are adding it, either you add towards this side or this side. See, for the first one, if you do, this comes as minus 1 plus of minus 2 by 3. That means minus 1 minus 2 by 3 is minus 3 by 3. Clear? Now, when you make it other way round, that comes as minus 2 plus of minus 1. Again, it comes as minus 2 minus 1 by 3. Total is going to be minus 3 by 3. Now, when you go on this side, it is minus 1 by 3 into minus 2 by 3 is equal to minus 2 by 3 into minus 1 by 3. Now, the resultant here is 2 by 3. Here it is also 2 by 3. Clear? That means the commutative law under addition and multiplication also closed for rational number. Okay? The third property, that was associative law for addition and for multiplication. Here A by B plus C by D plus E by F, where A by B, C by D, E by F are three different rational numbers. So as we have seen in the commutative law and for closure law, that when we add two rational number, we are going to get the same rational number. So from the commutative, you can say that A by B and C by D will give you again a rational number. Again, adding two rational number, you are going to get the same rational number. Similarly, if the order is changed also, A by B is added to the sum of C by D plus E by F, the answer is going to remain same. That is, in mathematical language, if we say that LHS is equals to RHS for addition. Similarly, for multiplication, as A into B is equal to B into C, we can say, remember the concept for whole numbers, A into B into C. That is, product of A into B multiplied by C is equal to product of B into C multiplied to A. Clear? If we recall that, and if we substitute the values of A by B, C by D and E by F, we are going to get the same conclusion, LHS equals to RHS, and hence we can say that the associative law for addition and multiplication is closed for rational numbers. Or now next one is existence of additive identity for addition, existence of multiplicative identity for multiplication. Now here what does we need to understand is, there is a number 0 which when added to the rational number, may the order differ, the rational number is going to remain the same. And for multiplicative one, the identity is 1. It means when you multiply any rational number by 1, the rational number is not going to change, it's going to be the same. Only concept to be remembered, for addition, the additive identity is 0, and for multiplication, multiplicative identity is 1. Now, one more thing to tell about the inverse. Now, additive inverse. What is additive inverse? If we reverse this, it becomes when a by b is a rational number, we are talking about additive inverse. Similarly, we will be talking about multiplicative inverse. Now, for additive inverse, what can be added to this number so as to get 0? This is additive inverse. You need to add just the negative rational number of the given one to the present one to get it as 0. And for multiplicative inverse, if it is a by b, by which number will you multiply it to get as 1? So, you will be reversing it, b by a, whatever be the rational numbers, whether it is negative or positive, including the sign, it has to be reversed. Clear? So, what we have learned so far? We have learned that for rational number, closure property, commutative property, associative property, existence of additive inverse, existence of multiplicative inverse, existence of additive inverse and multiplicative inverse, multiplicative identity and additive identity. Clear? Now, we need to go for, what we have done so far, we have learned the definition, we have learned the type of rational numbers as positive and negative, the property related to rational numbers, that when we multiply the given rational number by an integer, we get an equivalent rational number. When we divide, we get another equivalent. How to compare and say whether the rational numbers are equal or not, that is product of the numerator of first one and the denominator of the second one, that is if a and b and c by d are two rational numbers, then a into d is equals to b into c. If this satisfied, we can say that the rational numbers are same. Apart from that, we have learned about the property. Now let's go for the representation of a given rational number on a number line. Hope you remember what is number line? A line which consists of all the negative and positive numbers. So we are going to represent minus 1 by 2 and 1 by 2 on number line. Clear? So, let 0 be here. We are going to take a unit distance 1, unit distance 2. Similarly, this side, this becomes minus 1, this becomes minus 2. Now, look at the denominator. The denominator is 2. That means between the unit distance equally divided into two parts. So, this, if it is half, this will be minus half. So, this is minus half, plus half, and this is minus half. The representation of minus half and 1 by 2. Let's take one more example. Like if you need to represent 1 by 3, what you will do? You will draw a number line. Yeah. Then here it is 0. Take a unit distance 1. Equal divisions between 0 and 1. How many equal divisions? 3 equal divisions. Clear? So we will be dividing it in 3 equal divisions. Which part we are talking about? 1. So the first one is this. This is the first part, this is the second part, this is the third part. That means 3 by 3, 2 by 3 and 1 by 3. What we need to highlight? This. This is 1 by 3 and this 3 by 3 will come as 1. Clear? So in short, we need to divide the unit distance in the equal number by seeing the denominator and then understanding which particular position we need to mention. Now what happens if it is 5 by 3? If it is 5 by 3, recalling fraction, you know that 5 by 3 is nothing but, it is nothing but 1, 2 by 3, 3 ones are 3 plus 2. That means this number will come somewhere more than 1. So extend this, let this be 2. Again you need to do the 3 equal divisions. 2 and 3. So this division is 6 by 3, that is 2. This is 4 by 3 and this is 5 by 3 we are talking about. Clear? So I hope the concept is clear. Now easily you can represent the numbers on number line. After representing numbers on number line, rational numbers on number line, let us find given 2 or 3 rational numbers. If 2 rational numbers are given, we need to find the numbers between them. Okay, let's take an example of 2 and 3. We need to find 2 rational numbers between 2 and 3. Now how will we find? Let this be A, this be B. Clear? Or you can say 2 by 3 and 3 by, not 3 by 3, let's change it as 5 by 3. Clear? We need to find 2 different rational numbers between 2 by 3 and 5 by 3. If this is 1, this is the second one. What we will do, we will just add these 2 numbers and divide it by 2. This is nothing but half 2 by 3 plus 5 by 3 will give you 1 by 2 into 7 by 3. That means 7 by 6. That means one number between these two is 7 by 6. Clear? Now similarly, if we want to find another 2 numbers, what we will do? We will take, this is A and this is B. This is A and this is B. That means half 2 by 3 plus 7 by 6 will give you the second number. And for the third number, it is 7 by 6 plus 5 by 3 and half. So I hope it's very easy and you can calculate and find the other remaining 2 numbers as a part of your assignment. Now let's meet in the second session where we will be discussing about the property of rational number for subtraction and division. Thanks for now.